2:10 a.m., Persian Gulf. A faint signal suddenly appears on an Iranian radar screen. At first, it looks like nothing more than a small disturbance in the noise, the kind of flicker operators see countless times during a long night shift. But within seconds, the atmosphere inside the control room changes. A sweep order is issued. Patrol units are redirected. Every sensor in the area begins searching the dark water. 60 feet below the surface, 4 SEAL operatives are pressed against the muddy seabed, completely still. Above them, the propellers of an Iranian patrol boat carve through the water with terrifying force. The vibration rolls through the seabed and passes straight through their bodies. They can feel the pressure, the weight of the metal hull above them, and the thin line separating silence from disaster. They cannot rise. They cannot signal openly. They cannot make a mistake. One uncontrolled movement, one stream of bubbles, one sharp sound in the wrong direction, and the entire covert mission could turn into an international crisis before sunrise. But to understand how this carefully planned operation nearly collapsed beneath the muddy waters of the Persian Gulf, we have to go back to the moments before the dive, when a flawless multi-domain plan met the harsh and unpredictable reality of one of the most sensitive waterways on Earth. The Strait of Hormuz is not just a narrow passage of water. It is one of the world's most important lifelines. Every day, around 21 million barrels of oil pass through this corridor, making every shadow beneath the waves strategically important. Below the surface, Iran had built a hidden nerve system made of fiber optic cables. These underwater lines helped coordinate fast naval units, coastal surveillance, and long-range defensive systems around Bandar Abbas. In a region where seconds can matter, that cable network functioned like the brain of a much larger machine. This time, however, Tehran had not only laid the cable, it had protected it. An underwater defensive layer had been prepared around the network, designed to detect movement, metallic signatures, and unusual activity near the seabed. Any team attempting to approach would not only need to survive the environment, they would need to move through a silent maze of sensors without waking the system. Far from the cable route, an old support vessel drifted slowly across the dark water at 8 knots. Its outline looked unimpressive, almost forgotten, like a worn-out civilian boat moving through the Gulf at night. On radar, it resembled a local fishing craft. That was exactly the point. Behind that disguise, however, the vessel was part of a much larger operation. Its hull carried a secure communication relay and served as the drop-off platform for 4 elite operators from SEAL Team 3. Under the cover of darkness, the men slipped quietly from the side of the ship and disappeared into the black water. Their rebreather systems came online, their dive sleds began to move, and within moments they were descending toward the seabed, where sand, mud, and darkness swallowed almost everything. At 60 feet deep, the team formed a tight diamond pattern and pushed forward through a dense underwater haze. Visibility was no more than 4 yards. Every movement had to be slow, controlled, and deliberate. One wrong angle could stir the mud and blind the entire formation. The current fought them from the side. The seabed shifted beneath them. The clock kept counting down. Exactly 90 minutes remained. The lead operator raised a sonar tablet, and after several tense seconds, faint glowing lines appeared on the screen. The cable network was there, hidden beneath the seabed, exactly where intelligence had predicted. Tehran had presented this underwater system as nearly unreachable. Yet at a depth of roughly 20 meters, the SEAL team was now moving directly toward the core of that hidden network. This was not a simple dive. It was a race against time. The entire operation depended on coordination between the sky, the sea surface, and the ocean floor. Every domain had a role. Every platform had a purpose. And if even one part of the system failed, the team below would be left with almost no options. The old support vessel continued drifting at 8 knots, maintaining the appearance of a local boat with no military value. Further out, an Arleigh Burke-class vessel held position near international waters, operating in strict silence. Its radar and radio systems were kept quiet to avoid drawing attention from Iranian monitoring units. Nothing about the surface picture was supposed to look unusual. No sudden movement, no aggressive posture. No obvious sign that a high-value operation was unfolding below. Meanwhile, beneath the water, the USS Virginia had been waiting near the deployment area for nearly 48 hours. Its task was not to reveal itself, but to listen. It mapped the acoustic environment, studied the thermal layers, and tracked how sound moved through the water. Using passive sonar, it identified engine patterns in the area without sending out active signals. From there, it passed carefully limited navigation data to the SEALs through short-range acoustic pulses. These signals helped the team move through the mud with extreme precision, even in conditions where human vision was nearly useless. Above the Gulf, a P-8 Poseidon from the USS Abraham Lincoln Carrier Strike Group maintained its orbit at around 20,000 feet. To anyone watching, it looked like a routine surveillance flight. That was the cover. In reality, the aircraft's sensors were focused on Bandar Abbas, watching the movement of patrol boats and fast naval craft. If anything launched from the port, the team below would need to know immediately. This invisible surveillance ring gave the divers a 360-degree protective picture without openly revealing the real objective. To Iranian sensors, the surface and air activity appeared ordinary. Underwater, however, every second was being measured. At the seabed, the team reached the target area and prepared specialized cutting equipment. The goal was not to create obvious damage. The operation had been designed to leave behind a scene that looked natural, accidental, and difficult to explain. Instead of leaving a clean artificial mark, the equipment created an uneven angled break, the kind of rough disruption that could resemble natural erosion, shifting seabed material, or an anchor dragging across the bottom. If Iranian divers inspected the site later, the evidence would not point clearly to a hostile operation. It would look like the Gulf itself had done the work. That was the entire forensic layer of the plan. Delay the response, confuse the investigation, and push Iranian engineers toward a technical explanation rather than an outside source. But during the final positioning phase, the mission hit a serious complication. The cable was buried deeper than expected. The shifting mud had swallowed more of the route than intelligence had predicted, making the core harder to locate. The SEALs needed a more precise fix. Without it, the payload could be placed incorrectly, wasting the entire mission. To guide the team to the exact point, the Virginia was forced to send a single high-intensity acoustic pulse. It was meant to be brief, it was meant to be controlled, but the Persian Gulf had its own surprises waiting. That pulse triggered an Iranian underwater defense asset known in the scenario as Ajdar, an unmanned submersible assigned to protect strategic infrastructure beneath the water. It was not patrolling randomly. It followed a pre-programmed route near the cable network, waiting for anything unusual. Unlike basic underwater drones, Ajdar carried sensors designed to detect magnetic anomalies. It picked up the acoustic pulse, then identified the faint metallic trail left by the SEALs' dive sleds as they moved through the mud. The drone broke away from its patrol path. Its nose sensors turned toward the disturbance. Then it began moving directly toward the team. Ajdar had a built-in escalation protocol. If it confirmed an intruder near the cable, it would rise toward the surface and transmit an encrypted alert to the Bandar Abbas command center. That meant the SEAL team now had only 12 to 15 minutes before a hidden underwater mission became a visible geopolitical emergency. They were 60 feet down, their oxygen window was narrowing, a robotic hunter was closing in, and above them, Iranian patrol boats were only minutes away from reacting. At 2:45 a.m., as Ajdar accelerated toward their position, the team shifted into emergency containment mode. The goal was not to destroy the drone. Destroying it could immediately trigger a missing signal alert. Instead, they needed to confuse it, disrupt its sensors, and keep it from reporting anything useful. One operator raised a compact electromagnetic tool and aimed it at the approaching submersible. A focused burst of low-profile energy moved through the water, tuned to interfere with Ajdar's navigation and detection systems. The drone did not explode, it did not vanish, it simply lost its certainty. Its magnetic sensors became unreliable, its internal navigation drifted, its movement turned unstable, as if the machine had suddenly forgotten where it was supposed to go. For a few precious minutes, the robotic hunter was no longer hunting, but that action created another problem. At 2:55 a.m., the emergency device also sent an encrypted signal to the surface. Once received, the Arleigh Burke-class vessel beyond the horizon initiated a broader electronic cover. This was the moment the operation moved from silent underwater precision into full-spectrum concealment. A system described as CWIP Block 3 generated a localized digital fog around the area. Its purpose was to absorb, confuse, and disrupt any backup transmission the drone might attempt to send, whether through acoustic modem or satellite relay. To the outside world, the area would appear normal. Inside that invisible bubble, however, signals could disappear before reaching shore. For a moment, the plan seemed to be back under control. Then the Gulf answered with something no electronic screen could easily block. At 2:58 a.m., a buried passive acoustic trigger near the fiber optic node activated. This system was low-tech, old-fashioned, and extremely difficult to counter because it did not rely on normal radio communication. The sudden spike in electromagnetic activity had awakened a secondary mechanism hidden in the mud. A rhythmic, high-intensity ping began echoing through the water. Not a digital alert, not a satellite message. A physical sound, a mechanical distress signal that cut straight through the electronic fog and traveled across the seabed. Two Iranian patrol boats waiting roughly 3 nautical miles away picked up the sound almost immediately. Their crews changed course and began moving toward the area at high speed. The countdown had dropped to 8 minutes. The SEAL team was now trapped between a confused underwater drone and approaching surface vessels. Worse, their location was being marked by a signal they could not simply switch off. At 3:07 a.m., with the patrol boats closing fast, the operation entered its most delicate phase: deception. The only way out was to make the opposing side believe the activity was somewhere else. Beneath the deeper water, the Virginia deployed acoustic decoys. These devices generated a convincing underwater signature, imitating the sound profile of a large submarine moving away from the real location. To Iranian sonar operators, it looked as if the main underwater source was escaping in the opposite direction. At the same time, the P-8 Poseidon released a series of precise acoustic buoys into the water. Once they landed, the buoys began transmitting synthetic sounds of grinding metal, tool movement, and intense underwater activity roughly 400 yards away from the SEAL team. To anyone listening, it sounded like a U.S. unit was working frantically at the wrong coordinates. The deception worked. Iranian attention shifted toward the false location. While patrol crews focused on the artificial noise, the SEALs returned to the real objective. At 3:15 a.m., they prepared the final payload, a micro-fault injector. This was not designed to break the cable completely. A total break would be obvious. It would be repaired. It would create immediate suspicion. Instead, the device was meant to create small, intermittent disruptions inside the fiber optic core. Not enough to fully shut the system down, but enough to make it unreliable. A delay here, a data flicker there, a command arriving a fraction too late, a coordinate drifting slightly off mark, a video feed freezing for less than a second. On their own, these problems would look like ordinary technical failures. Together, they would quietly weaken confidence in the entire command network. That was the real objective. Not noise, not spectacle, uncertainty. At 3:23 a.m., the psychological effect of the mission became clear. If the cable remained physically intact and the errors appeared only at random intervals, Iranian engineers would likely spend days or even weeks blaming components, software faults, or environmental issues. Meanwhile, the hidden device would keep creating subtle confusion inside the Bandar Abbas command and control network. While naval units chased the false acoustic trail 400 yards away, the 4 SEAL operatives began cleaning the site. Every tool was checked. Every disturbed patch of mud was smoothed over. Every trace of human presence had to vanish into the seabed. The patrol boats were searching a ghost. The real team was already preparing to leave. By 3:30 a.m., as the Iranian crews continued responding to the false underwater signatures, the SEAL team moved toward the backup rendezvous point. They swam nearly 1,000 feet along the seabed, staying low and slow, letting the mud and darkness hide them. 4 dark shapes finally surfaced near the old support vessel. Equipment was pulled aboard quickly. The vessel never changed its behavior. It continued drifting like a tired civilian craft, maintaining the same quiet profile it had shown all night. By dawn, the SEALs were safely back aboard the Arleigh Burke-class vessel. On the surface, the Persian Gulf looked calm. Nothing about the morning suggested how close the night had come to disaster. In Bandar Abbas, engineers would later see only a frayed and distorted cable section, something that could easily be blamed on seabed movement, a heavy anchor, or natural wear. What they would not see was the micro-fault injector hidden inside the system. Over the following 14 days, Iran's command network would begin suffering small but confusing failures. Fast boat orders would arrive late. Guided system coordinates would drift by meters. Coastal sensor feeds would freeze at exactly the wrong moments, not long enough to prove outside interference. Just long enough to make commanders doubt their own network. That was the genius of the operation. It did not rely on loud action. It relied on silence, timing, and controlled uncertainty. The opposing side was not shown a clear problem. It was handed a mystery. A billion-dollar network had not been visibly broken. It had been made unreliable. And in a high-pressure environment like the Strait of Hormuz, unreliable can be just as powerful as disabled. The mission showed how modern naval power is no longer measured only by large ships, visible force, or dramatic movement on the surface. Sometimes the most important battle takes place where no one can see it. Beneath the seabed, inside cables, inside data flow, inside the few seconds between a command being sent and a response being received. The combination of silent divers, a Virginia-class submarine, surface support, electronic cover, and airborne surveillance created a layered operation where every platform had a backup and every backup had another plan behind it. To the outside world, it looked like empty water. Underneath, it was a chessboard, and every move had to be made without sound. This is the message behind the scenario. Silence should never be mistaken for weakness. In modern maritime operations, the quietest move can sometimes create the largest strategic effect. If the electronic cover had failed, if the drone had surfaced, or if the patrol boats had reached the correct location in time, the mission could have shifted into a much more visible confrontation. But the entire design was built to avoid that outcome. The real victory was not in escalation, it was in leaving before anyone could fully understand what had happened. By sunrise, the team was gone. The support vessel was just another shape on the water. The radar screens were quiet again, and somewhere beneath the Gulf, hidden inside a cable that still looked functional, a tiny device had already begun changing the balance of the region, one subtle error at a time. So the question is simple. If this happened once, how would Iran respond the next time it suspects that the real battlefield is not on the surface, but deep beneath the waves?